Let's start our review of Topic 3, Anticipating Patterns. This is going to cover chapters 5 through 7, and we're going to spend 5 days doing that. It'll be days 10 through 14 in our review. So let's just talk about the review related to day number 10. So today's review is just going to be about chapter 5, which is our general probability. We had 3 different sections in there. Some of the key things we talked about are general probability rules, probability distributions, or probabilities is where you add, general multiplication probabilities, and conditional probabilities. Let's talk about the separate sections and what was important in those. Section 1 really highlighted the difference between law of large numbers and probability. Remember, probability, some of the key things you want to focus on is saying things that are about in the long run. So it's the relative frequency in the long run. It's very important. Probability can only be between 0 and 1. The law of large numbers, the more and more you do something of an experiment, the closer your answer is going to get to the true theoretical probability. We also looked at simulations. So as we did a simulation, we could do things more and more times and try it out, and we would see if we simulated the scenario, maybe we could compute the actual probability. Simulations are nice to use when you have trickier and harder probabilities to really think through. Section 5.2 introduced the probability model, which is how we looked at it as a table. Remember, with the outcomes and then the various probability percentages below. We also addressed just the standard probability calculation, how to deal with the complement rule, which can be a nice trick to evaluate some probabilities if they're harder to think about. Introduced the definition of mutually exclusive. Another word for that is disjoint. Mutually exclusive basically means that the two events have nothing in common. So if you're trying to find an OR probability, that is a probability of A or B, remember OR probability is always you add. That's what OR means. If they're mutually exclusive, there's nothing in common, so you do not have to worry about a third component, which is some overlap. Now, if they are not mutually exclusive, means they have something in common, what you need to do is use this particular OR formula. This is found on your formula sheet, and remember the key to this one is that it's going to have you do, because it's OR, this is the union symbol, that also means OR is shorthand. You're going to add the two events together, but you subtract out what they have in common. Remember, this is the intersection symbol, which means and. So the probability of A and B happening at the exact same time. They also talked about some Venn diagrams, which can be helpful if you're trying to see kind of the intersection. So if you do a Venn diagram, you're going to see your intersection or the and component right in that overlap on the two circles. 5.3 then addressed conditional probability. Remember the format for conditional? This statement as it's written just means the probability of B given that A happened. All this really is a subset. So if we have a complete population, we're just looking at the A value, given that A happened, so that's the subset. For independence, independence, remembered, means that two events, one event will not impact the outcome of the other. What you can do to test for independence, there's really 2 tricks. A general rule they're going to say is if you find the probability of B given A and it equals B, then if you reverse it, the probability of A given B equals A. So really what we're looking at here is that when you do this scenario, you're going to get B back. When you do scenario A, you're going to get A back. If these 2 statements are correct, or they equal each other, it means that the events are independent. Now do recall that independence does mean that the first event will not impact the outcome of the second event. This statement right here is actually a really important one to make note of. It says here, if events A and B are mutually exclusive, which means they have nothing in common. So if they're mutually exclusive means the probability of A and B, if they are mutually exclusive, would have to be 0. It says here, if that's the case, then they cannot be independent. If they have nothing in common, then what you'd have to say, if they are mutually exclusive, then they can't also be independent. One cannot impact the other. So these 2 things, mutually exclusiveness and independence, can never ever happen at the exact same time. So that's important to keep in mind. Now there's another way to actually prove independence. I personally like this one right here instead. I've never been a big fan of having to memorize this 2-part component for the independence test. This right here, what we do know is this. If 2 events are independent, if it's the case that A does not impact B, then this statement would be true. So if you are asked if two events are independent, you could actually use this particular statement here and actually show if it works or it doesn't. If this is a true statement mathematically, then we know the two events are independent. But if this side equals something different from that, then they're not independent and you could use it. Another formula you're going to find on the formula sheet is for conditional probability, and that's this guy right here. Remember, it just means the probability of B given that A happened. So A is our subset, so that's the probability you put on the bottom, and it's over the probability of A and B at the top. This is on the formula sheet. You could use this formula right here, or sometimes if they just give you a two-way table, I literally look at the two-way table, find the subgroup, and just come up with my own numbers, and then that's all you really have to do. So with that being said, that's really what Chapter 5 was about. We're now going to jump on in to today's multiple choice questions. So again, take a look at those and good luck. See how you do on your first try and just give one solution for that. And then the free response for Chapter 5, where the answers are posted, is going to be from 2001, it's number 3. They are going to ask you to explain the simulation of how that would work and to actually conduct a simulation. So this one is showing you how to do a simulation to estimate a probability. So try this free response, go into the actual assignment, and please look at the scoring rubric and see how you do. Good luck for today as you venture into days 10, the first day on your topic 3 review.